So today topic is power system analysis module 3. In that we are going to see symmetrical components theory or symmetrical component method. So this symmetrical component methods is mainly used to find out or to solve the problems of unsymmetrical fault. Even though the module 3 we are having symmetrical component, but in this method we are going to use mostly for unsymmetrical problem. So that is the first point. And I'll write here used to the problem of unsymmetrical fault that we are going to solve in module 4. Okay, but this method is used there to find out the unsymmetrical fault. And previously in the initial stage of this module 3 we have discussed about the symmetrical problem and fault current, fault power, and then voltage. If some part of voltage is need to calculate, all those problems we have solved. Okay, and this method is given by Dr. C.L. Fortescue in 1918. That is 100 years back. So this is the person who given the method of symmetrical component method. What he said is, say for example, for an unsymmetrical three-phase or unbalanced phasor, say for example if I draw the current in phasor diagram like this. Say for example this is current R phase and this is the current Y phase, and then this is the current for B phase, RYB, right? Three phases. So B phase. So this is if you see there is no balance. I mean all the phasor or phase difference between all these three phasors are different, not 120-degree phase shift or not evenly splitted. And this phasor is rotating in anti-clockwise direction. So this is called as three-phase unbalanced power. Phasor, unbalanced phasor, and this is not 120-degree shift is there, phase shift is there. All are unevenly. So obviously this is an unbalanced system. This phasor diagram is an unbalanced system. What this method, symmetrical method, is telling is this unbalanced phasor can be represented by three different balanced systems. What is that? This unbalanced three-phase phasor can be represented by three different set of balanced phasor. Okay, I will write here. In next slide I will tell how it is happening. So a set of three-phase, very important, set of three-phase unbalanced phasor can be represent represented by represented by three different set of balanced phasor. Balanced phasor. Okay, one more point I will add after explaining the diagram. I will add here. So I'll go to next slide. Before that, I want to copy this. So this is the unbalanced phasor. What is the definition is? This unbalanced phasor can be represented by three balanced phasor. So first phasor I will write here. Which what color I can take? I can take three different color I will use for three different set of phasors. So first I will take maybe maroon or dark red. So this is the point. Okay, so I will take this as phase Y, and I will call this as 1 because 3 I need to draw. Maybe 0 is there, 0, 1, 2, 3. Sorry, 0, 1, 2 is the three different phases. I will first start with 1 and then 2 and then I will go for 0. Okay, and 120-degree phase shift it is having because I said that this unbalanced can be represented by three balanced system. So I will take a balanced system of 120-degree phase shift and I will call this as IR1, and here it is IB1. So three phases having 120-degree phase shift. 120-degree phase shift. And this is also rotating in the same direction of our unbalanced phasor. Just my aim is to represent this unknown or unbalanced phasor with reference to the balanced phasor. And second sequence or second phasor, I will take some other color. We will take dark green and I am drawing here. So here what happened, it is rotating. Okay, because of the rotating, let I take like this. So I am starting from here and this phase is my okay, I will take Y because previously Y I took, so I will take Y first. So Y is here. So Y2. After Y, what is there next? Here it is R. But after Y, for me, if it is rotating in this direction, it should be after Y it is R. But here I am taking after Y IB2. IB2. This is another set of sequence because as I said I want to represent balanced three type of phasor into unbalanced phasor. So I will take one more here, and this is nothing but IR2. So what is different between IR1 and IR2 is, see here YBR, here YRB. Okay, so the phasors inside the sets are different, but the phase shift are same. It is 120 degree, here also it is 120 degree, and here also it is 120 degree. So this is 2. 1 is over, 2 is over, and then third one I am taking like this. What is this? This is also a phasor diagram, but all the phase are going in a same direction, moving in the same direction. And this is also what balanced system. This is also balanced system. So I will take this as IR0, IY0, and then IB0. So these are all the three different phasors and three different balanced phasor. With this balanced phasor, I can able to what? Represent my unbalanced system. This is the theory given in the symmetrical component. How? We need to prove it. Maybe in question they will not ask prove whether the three are same, but you can draw and tell them how it is same. How these three balanced can be represented to an unbalanced phasor. And one more thing, please note that all these four or all these three, this side, these three are rotating. At any moment, if you are taking reference of IR, this IR will be taken reference for this IR1 as well as IR2 and then IR0. And at any moment IB, if you are taking, IB is the original current. This IB1, IB2, IB0s are imaginary or it is not existing. In real time it is not existing. That is the important theory you need to understand. These are all mathematically we are representing, but IB in the three phase unbalanced phase is existing, real one. But this IP indirectly mathematically these three components are available there. That is why they have splitted. Mathematically they have splitted that IB into three components. That is they named as zero sequence. Okay, actually I should draw in different color. That is okay. That is zero sequence. Okay, I will draw it because I'll take one more color for zero sequence. This is IR0, IY0, and this is IB0. So this one they will call as zero sequence component. Then this is positive sequence component. And this is negative sequence component. This is negative sequence component. So the unbalanced phasor diagram, three-phase unbalanced phasor diagram can be represented by zero positive negative sequence component. With addition of these three, we can able to get this value. So this is the theory given by symmetrical component method 100 years back before. 100 years before they have given this theory. How it is going to work. Let me draw it. Okay, so I'll try take the because it is not coming. Okay, I hope that you written in the note, right? Have you take this in the note? Please take it in the note. So I'll take first positive sequence. Okay, so it is in the red color, so I'll use the same red color here. So what is this? IR1, right? This is IR1. And what is this? Please tell me. IY1. And this spacer is IB1. So this is the positive sequence I have taken. Next, in the end of the positive sequence, I am going to draw negative sequence. So where IR1 is coming, IR2 is coming here. IR2 is coming down, correct? This is coming down. So I will take IR2 down, little bit down. So this is IR2. I will take different color. So before that I will draw first the unbalanced system. So unbalanced system is I taken like this. IR, this is the actual system, and then this is IY, and this is IB. So as per the theory, if we add all the three sequence or all the three symmetrical balanced sequence into the network, I will get this original value, that is unbalanced phase, right? So first I will take the red one. So this is nothing but, why I am taking small is, say the magnitude may change but phase of that angle is constant, right? So this is IY1, and then IB1, this is IR1. Next, green. Actually, because of the hand drawing, the angles are different, but if you are drawing with protector, you will get exactly as per the theory they have given. So where is IR1 here? IR1 is here, and IR2 is going down. So I will draw IR2 going down. So this is IR2, and IB2. Where is IB2? Is straight line. So IB2 is straight line, and then this is IB2, and then and IY2. IY2 is going upward. IY2. Next, I am going to add zero sequence in the following. So zero sequence is the blue one I have chosen. So I'll take the blue one. All are in same direction. So this is IR0, and this is IB0, and this one is IY2. So if I draw a line in this direction, I will get the original value. and if I draw a line from this point to this point, I will get the original value. And if I draw a point from here to here, I will get the original. Actually, the length we are not measured, but if you are doing in the calculation, we will get the exactly original value by adding all this balanced condition. If you are adding these three, we will get exactly, or we can represent exactly the same original value. So this is the formula, this is the theory of what? Symmetrical component. So symmetrical component is nothing but we can represent the unbalanced phasor but with three different balanced phasor. In this is fixed. Positive sequence is fixed, negative sequence is fixed. Only the zeroth sequence is going to be differ for different type of unbalanced system, because here we are not going to change anything. Where in negative sequence there is no any change, anyone will have the same direction only, and here also it is constant. Only variable is zero sequence, and this zero sequence without having angle, only this angle. So only this angle we need to calculate. How to calculate that is to get zero sequential component, this one. So to get this zero sequential component, add all the three unbalanced phasor, take 1/3 of that value to get direction of zero sequential. So what they are telling, add all these three, this angle, this angle and this angle, add all these three and put 1/3 and that angle, and what angle you are getting, that is your zero sequential angle. That's all. With this zero sequential angle, you will get different values like this for different values. So in this angle, all these three are going in this angle, or all these three is going in this angle. So after adding sequential, positive sequential and negative sequential, zeroth sequential you are going to add at the third position. During that time, which angle you are going to draw? 1/3 of the total angle of your unphased angle, unbalanced phasor angle. So only calculation you need to do is to get the sequential component is the zeroth sequential component. For this, nothing but you add all the three angles of your unbalanced system, divided it by 3, and that is your zero sequential component angle. Simple, right? In my handwritten notes, the diagram is very clear. Okay, this diagram. Actually, I tried my best, but in this notepad it's not coming properly. But in handwritten notes, I have used scale and pencil, so I have drawn clearly. You can use my notes. Okay. Only thing is, see, you are going to add all these three components, or we can able to represent the unbalanced system with three balanced system. Why? Because say for example, for unknown quantity, for any unknown or unknown value, we can able to calculate by known value. That is what they have simplified this version to find out the unknown quantities, right? So these are all the this is the main theory of what, sequential components. You need to understand this. There are positive sequences there, negative sequences there, and zero sequences there. Next, they are introducing something like alpha. Alpha is nothing but angle. This alpha is always, remember, one angle 120 degree. One angle 120 degree, alpha. If that is the case, we are having different variables here. What are those? IB we are having, IY we are having, R we are having. This is the main or unbalanced phase, original value, and we are having zeroth main. I will write here main, and positive sequence we are having, negative sequence we are having, and then zeroth sequence we are having. For this, for positive sequence, what is the value for B? That is IB1. For negative sequence, IB2. For zeroth sequence, IB0. Please familiarize with it. And then this is I1. IY1 is for positive. IY2 is for negative. IY0 is for zero sequence. IR1 for positive sequence. IR2 is for zeroth negative sequence. And then this is IR0 is for zeroth sequence. So this you need to familiarize. Now, by seeing a positive sequence, we know that, okay, I will take here. So this is what? Positive sequence. This is negative sequence. So this IR1 can be written, say if 120 degree is equal to alpha, then IB1 I can able to write IB1 is equal to alpha into IR1. Correct or not? Can I write like this? Alpha into IR1. That is nothing but this is IR1 only. Magnitude is same. All these three are same magnitude. So magnitude is same. Only angle, if I multiply it with 120 degree, I will get IB1. Correct or not? Please tell me. This is okay, right? Students, please respond me.
Yes, sir.
Okay. Then what will be my IY1? IY1 is equal to, can I write alpha square IR1? Alpha square IR1. Can I write it? Clear or not? Please tell me, ma'am. Huh?
The whole square.
Actually, in angle, if you are calculating, we need to make it as square in angle. In magnitude, we will put addition, right? Correct or not?
So then in that case, is it alpha cube for IR1 or something else?
If you put alpha cube, it is 360 degree, right? Again, it will come 0 only.
Okay, sir.
Okay, it is 360 degree, then it will come 0 only. So, in angle, we need to square it. Similarly, say for example, if I am taking R as a reference for both the R as reference I am taking. You can take Y also or any reference you can take. If I take same R here for the negative sequence, so how I can write IY2? IY2 is equal to alpha into IR2. And what will be IB2? Alpha square into IR2, because both the case I have taken R here as well as here. Both the cases I have taken R. So if I take R here also, so R, if I want to convert all the Y and B with R, then I will put IY2 is equal to alpha into IR2 and IB2 is equal to alpha square into IR2. So I will write here. Please note down IR1 IB1 is equal to, this is IR1 itself, IB1 is equal to alpha into IR1. This value will come for entire problem for sequential component. Please note down these values. And then IY1 is equal to alpha square IR1. Similarly, IR2 is equal to IR2 IY2, or I will take IB2 is equal to, what is the value for IB2? Alpha square into IR2, and IY2 is equal to, what is the value? Alpha into IR2. Clear? And we know that for zeroth sequence there is no any angle. Say for example, this is I r 0, I b 0, and this is I y 0. I will write I r 0 is equal to I b 0 is equal to I y 0. Both all three are same. Magnitudely it is same, and angle is 0. There is no any angle mean phase difference between all this for zeroth sequence, zero sequence component. I r 0 is equal to I b 0 is equal to I y 0. Clear? Is that clear? Please write down these values. These are all the important values while calculating the formula. I mean, while calculating the problems, these are all the important values. Please note down. Next, we know that this IR, original R, that is the unbalanced system, original IR can be calculated by, what is the theory they have given? Calculated by IR0 plus IR1 plus IR2. Here one question I will ask. So what is IR0, IR1, IR2? What is this, ma? We know that this IR is unsymmetrical. This unsymmetrical can be represented by three symmetrical components, and this is the zeroth component for R phase, and this is what positive sequence component for R phase, and this is negative sequence for R phase. Similarly, for Y phase, IY0 plus IY1 plus IY2. Similarly, for B phase, IB0 plus IB1 plus IB2. Okay, so all three phases we can able to represent with the summation of the three symmetrical components, that is the value. Now if I want to convert this equations into a matrix form, so we know the values of these things. What is the why I am doing that? Because I want to convert everything into a single value or R value. Okay, say for example I am taking this as the reference of R, as I said earlier. So let me check how it will be happen. So for this, so how I can able to this IR is equal to same, there is no change. IR0 is same plus IR1 is same, because I am taking R as reference, so it will come same thing. IR2 is same. Next, IY, I want to change all the Y value into R phase. So tell me, what is the value of IY0? What is the value of IY0, ma? What is the value of IR0, right? What is that? What is the value of IY0? I want to convert it into R. All the values here, like IY1, I2, IY2, IB1, IB2, IB0, YB0, all these values I want to convert into R. So, and also we know that IR0, IB0, IY0, all are same. So instead of IY0, I can write this IR0, right? Correct or not? So this is IR0. IY0 is nothing but IR0 also. Plus, what is IY1? What is IY1 value? IY1 value is? Yeah, please tell me, ma. Unmute yourself and then tell me, please.
Alpha square IR1.
Okay, so it is alpha square IR1. And what is IR2? Sorry, IY2. this value? What is IY2?
Alpha IR2.
Very good. Alpha IR2. So similarly for IB also, how you can write? How you write? I can write same as IR0, right? IB0 I can write as IR0 plus what is IB1? IB1 is
Alpha IR1.
alpha IR1. Alpha IR1. What is IB2?
Alpha square IR2.
Okay, alpha square IR2. So now I converted all the values into R value as a reference value. This is 2. So if I want to take the R outside from this matrix, I can write like this. So IR, IY, IB. IB is equal to, if I remove all this IR0, IR1, IR2 outside, so I will write like this: IR1, IR1. All these things are phasor. Please remember all these things are phasor. IR2, IR3. So what will be here? What is my value here?
Sir, I0
Sorry, ma. Thank you. So this is 1 and this is 2. Thanks. And what will be the value? So 1, 1, 1, right? Because there is no any alpha here in this line. And here if you see, here also it is 1 and 1. And you can see here alpha square. And here it is alpha. And here it is alpha and alpha square. Clear? Correct? So if that is the case, if I want to find out IR0, IR1 and IR2 current of the balanced sequence, current of the balanced sequence, if this current is given in the question, then we need to find out the current of the balanced sequence, that is this area. I want to find out the current of this one and this one, if this current is given to you. Okay, that time just I want to take what inverse of that. So if I keep this IR0 here and if I take the matrix that side, then it will be the inverse matrix. And also this summation, all this 1 by 3 times the original value of R1, that is IR1 or IR, IY, IB phases are the value of sum of all the three. What is that means? We know that this current, that is the current of this value, is splitted into positive sequence, negative sequence and zeroth sequence. So here also one current is there, partial of current is there, here also partial of current is there, here also partial of current is there. So if I want to find out any one, say for example 0 or maybe 1 or these things, 1/3 of part only will be available at any moment, at any sequence, whether it is a positive or whether it is, say, 1/3 of this one, 1/3 of this one, 1/3 of this one. So if I want to find out only for the 1 or 0 or 2, I will multiply always with 1 by 3, 1 by 3 times of the same value. So this also can be written as IR0, IR1, IR2 is equal to 1 by 3 times of inverse. If you take inverse of this by, or if you are calculating the equation, say for example if you are taking this as equation 1 and equation 2, this is equation 1 and equation 2 and equation 3, and if you are trying to solve this, you will get the value 1, 1, 1, 1 alpha square, 1 alpha square and alpha. I not solved this or substitute this, you can try by yourself. Okay, I have taken straight away the value, but what they have done is they have solved this 3 equation and they got this value, and reason for the 1/3 part is nothing but 1/3 of current of the original sequence is given splitted into all this all these sequences. So always we need to remember 1/3 of the value will be available at any sequence, whether it is a 0 sequence or negative sequence or positive sequence. 1/3 of current will be available. And why only we are focusing on the current? Because if you tell any system as unsymmetrical or unbalanced, it's not mean that the generated value is unbalanced. No, it is balanced. It does not mean that the impedance of all the values are different. No, impedance is same, and also the voltage magnitude is also same. Only thing is the current is what been unsymmetrical. Current is the only thing it got unsymmetrical. So we always focus only on the current when we are calculating the unbalanced system. If that is the case, we know that we are drawing this phasor for current only, and the total current, disturbed current in the three-phase phasor, three-phase unbalanced phasor, 1/3 of the part will be available at any sequential, whether it is a 0 or negative or positive, it will be 1/3. So that is why they have taken 1/3 part of the value and they have multiplied the original IR value, IR, IY, IB, original value. So they are taken like this. So this is the formula to find out the problem of symmetrical components. So symmetrical components is used to find out the unsymmetrical problems. So this symmetrical component theory you need to first understand.
Alpha matrix should be inverse now, sir.
Sorry? Yes, tell me, what is your doubt?
Sir, alpha matrix should be inverse now, sir.
Yeah, you can take inverse also, but they have solved this value. How they have taken this value is by solving this equation. By solving this equation, see this alpha to this alpha, they have interchanged, and this two they have interchanged. You can see this both are opposite.
Okay.
Okay, so this formula, you don't want to solve or you don't want to do the expression for this, straight away you take this formula for solving the problem. Even if you are asked any theory question, straight away you can write this as to find out the sequential current of any sequential. Say for example R, if they are taking R for zeroth equation, this one, for positive sequential, this you take this one, and for negative sequential you take this value. So this is the formula to find out the current at different sequential values. Okay, so just a minute.